Okay, so on the exam, the final, I would not use this same artwork. So if you want, you can just go Google, you know, Eulerizing a graph and just see some of the examples that are there. But the essay part of the question, or the verbal response to the question, what is required for an Euler path to exist? You need exactly 2 vertices having odd degree. Do not say 2 odd vertices. That doesn't make sense. Students say that all the time. That's not true. What about an Euler circuit? All vertices have even degree. Oh, also, and the graph is connected, but I'm kind of assuming that you know that. You know, mathematicians have to say these things. And graph is connected. I don't care if you say that because it's pretty obvious. In the graph below, is there an Euler path or circuit? Yes and no. If so, find one. Okay, so it needs labels. On the exam, I will probably give you labels, but if I don't give you labels, then you have to provide the labels. So let's say A, B, C, D, E, F, G, H, I, J, K, L, M, N, and then let's put numbers on the rest of them. 1, 2. Okay, so I could say A, B, C, D, E, F, G, H, I, J, K, L, M, N. Looks like what? So let's highlight this. A, B, I don't like that width. A, B, C, D, E, F, G, H, I, J, K, L, M, N. But I made this L capital so that it didn't look like a 1. So I'll make the 1 look like that. And I'll make the L a capital L. Now what do I do when I get to N? Anything I want, actually. Let's see. G, J, 1. Oops. Ah, that was an I over here. Sorry about that. That's why there was a dot on top of it. There, it's an I. Okay. And this one is the 1. These things matter. They take time too. 2. So where did I stop? A, B, C, D, G. Stopped at N. If you want, you can just give yourself a little dot here to say where you stopped last time. Or you can try to remember like me and remember wrong. Okay, so I've got a highlighter and I'm going to go to N, goes to G, goes to J, goes to 1, goes to 2. Now what? I'm sitting on 2, and I can go I, L, C, 2, E, H, M, D, A. See where that takes me. Okay, I'm going to go back to the highlighter, and it's yellow. I stopped on the number 2, it looks like, and I'm going to go I, L, C, 2. The 2 looks like a Z, but there's no Z here, so that's okay. E to H to M. Hi, Theodore. D, A. And so I'm stopping here at A, and then I have to go somewhere else. So let's say I go F, 1, B, K. N, A. Maybe I'll get lucky. Highlight, I stopped at A. Now I'm going to go F1, B, K, N, A. So that's my Euler circuit. And if I had come home to A and sealed off all my options of getting out, then what would remain will be another Euler circuit. And so what I would have done, for example, maybe I left out, you know, A, F, G, N, A. Then I would go to F, and any one of these F's, and I would say, oh, like insert in here, instead of F, I would say like F, A, N, G, F. Say whatever one I cross out has to occur twice. Something like that. Okay? But that didn't happen, so that would make this answer wrong now. But that's how you would go back and fix. And you don't have to rewrite the whole thing. You can just simply cross out the letter that you're replacing with an entire new circuit. And as long as it starts and ends with the F, I'll see what you did. Again, you would not expect a problem with this many things in it for the exam, but you know, you should be prepared anyway. And what about the accounting here? How many vertices? We have, in this case, we have something special. We have degree 4 on everybody. So with the exception of the first guy, which should appear 3 times, everybody else should occur twice. So let's see that we have 3 copies of the letter A. Yes, we do. And what about B? We should find it twice. B, B, that's good. And we have C, C, D, D, E, E, F, F, G, G, H, H, I, J, J, K, K, L, L, M, N. Where's the other N? N. And there should be 1, 1, 2, 2, and then I can say, oh right, that 2 looked like a Z, so I'm going to fix it. Okay, and if I see the little dots, I'll say, ah, great, they knew what they were doing. They probably did this one right.